completion of this chapter, the student should be able to explain the principles of digitalization of a radar echo, explain the principles of the tracking gate, recognize the need for target reference points, understand why there is a delay in the processing of targets, recognize the reasons for lost targets, and understand that target swap may occur in certain circumstances. The radar echoes that are visual on a traditional radar display are often referred to as video signals. These video signals are analog signals and have to be digitized before the ARPA system can use them for calculation. Most modern ARPA radars use a synthetic picture where the analog signals are digitized before they are displayed on the screen. The digitizing of the analog video signals can be done by dividing the transmission into equally spaced time segments. A digitized signal has only two values, off or on, often described by the numeric values 0 and 1. Then a threshold is applied where all the signals with amplitude below the threshold will get the value 0 and are defined as noise or no signal. Signals with amplitude above the threshold are given the value 1 and are defined as a target which is treated by the ARPA system. In order to acquire a target manually, the position of the target on the display must be pointed out by the operator. When the operator places the acquisition symbol on top of a radar echo, what he is actually doing is telling the ARPA system to search for a target in that position. Since each target is hit by several radar pulses and radar sweeps, the area pointed out must have a certain size in range and bearing. This area is called a tracking gate or tracking window. After sufficient data has been digitized inside the tracking system, the tracking gate may look like this. Cells marked with 0 indicate cells with radar signals with amplitude below the specified threshold, while cells marked with 1 indicate received radar signals above the threshold. A minimum number of 1s must be exceeded for the ARPA to start tracking the target. Each of the radar echoes that are acquired either manually or automatically is processed like this. For the ARPA system to be able to use the digitized echo for plotting calculations, it must be decided what part of the echo shall be used as reference. The different ARPA manufacturers use different positions on the digitized echo as reference for further processing. Possible target reference points are the front, the center, and the back. Each reference point has its advantages or disadvantages. When the reference point is set, the bearing and distance to this point is stored in the system. The next time the radar beam passes the target gate, a new bearing and distance to the reference point is found, and the ARPA can calculate the target's relative movement. Theoretically, an ARPA is capable of displaying target information after a few seconds. However, due to the many limitations in the radar itself, the average result from a number of radar scans must be calculated and used before the result can be displayed to the operator. A typical radar antenna rotates with 20 to 30 revolutions per minute. If the ARPA uses 12 scans to calculate target information, and we say the antenna rotates with 20 revs per minute, the processing time will be 36 seconds. Click the echo to get a feeling for the elapsed time. The ARPA tracking system will track a target continuously as long as the target echo is found for at least 5 out of 10 scans. If fewer echoes are found, the tracking will terminate and a lost target alarm is given. A lost target symbol will be displayed at the last valid position of the target before the data was lost. This symbol will continue flashing until acknowledged. There are several possible reasons for lost targets. Target becomes lost in clutter. Target enters a blind sector and can no longer be seen or tracked by the radar. The echo return is a weak signal and is intermittent. Targets that move out of radar range shall not trigger a lost target alarm. The size of the tracking gate will depend on the steadiness of the situation and the amplitude of the signal. When the tracking has been consistent for a while, the gate is reduced and kept as small as possible, just sufficient to see the target. This is important because if the window is too large, another target nearby could become confused with the target being tracked and take over the tracking from the original echo, and the display would experience what is known as target swap. The understanding of target swap is very important because it can lead to confusion. Sometimes one target may finish with 2 vectors and the other target with none.